Okay, say you want to go back in time and you kind of want to figure out like what you need. So in this problem, I need 40,000 in 5 years for a down payment on a house, and I just covered that up. That was what, 4.5% interest. And I want to know, what do I invest now? So okay, so what do I need to invest now to have this much money right there in the future? Obviously, I don't need to invest 40,000 because if I do, I would have interest on that and so forth. So, to get that much money in the future, I don't need to invest that much now. I could invest less and that will grow into that. All right. Now, this down here is our typical formula where you get a lump sum, you inherit some money, you save a lump sum, and you invest it. And then A is the amount of money in the future. We call this present value. This is your principal. This is the money today. You do some investing, it stays in there for 50 years, and then you have all this money when you retire in the future. But sometimes I want to know, I know the future, I know what I want in the future, but I need to know what I want to invest now. Now, I could just sub everything into this formula and then do algebra to get P, but most of the time in finance, we just manipulate the formula. So in this case, we want to get rid of this stuff. All right, so we have a formula that spits out the present value and it takes the value in the future and does math to that. So I'm going to divide both sides by, and again, you don't have to do this. If you want to do algebra, that's okay too. All right, and then over here, I'm going to do the same thing. All right, so these cancel. And so my formula is P equals, which is the principal or the present value, the money you're investing today, is going to be the amount of money with interest, which is your future value. That's what you're going to have in the future. And then here we have the rest of the formula. All right, so at this point, I am just going to sub in my thing. I know the future value. I know I want to have $40,000 divided by 1 plus my interest rate. It kind of got covered up there, but it was 4.5. N is how it's compounded, which is monthly, so that's 12. And how it's compounded times the number of years. So there it's compounded 12 months, and then there are 5 years. All right, so 12 times per month times that is what, 60. So 12 times, I should say, per month times 5 years is 60 times that it gets compounded. So on your calculator, you want to get an answer to this first and take 40,000 divided by that answer. Again, if you have a scientific calculator or graphing calculator that does order of operation, you should be able to just type in this divided by this. All right, now when I did that, and hopefully I typed this in right, I got 31,954, and looks like, what, about 9 cents? Okay, so if I invest that lump sum today, then 5 years from now, I would have $40,000 for a down payment. Again, assuming this interest rate, assuming it's compounded monthly and so forth. Again, this answer should be less because I'm not figuring out what the 40,000 will do in 5 years. I'm finding out how much money today will grow into 40,000. All right, so this is the formula you would use to do that.